Okay, number 7, they want you to find the length of segment CG. Well, CG is where the question mark is. So if you look at the triangle proportionality theorem, it says that you can take the pieces. You can take the pieces and make them a fraction. So 63 over 21 equals, you can take now these two pieces and make a fraction. 57 over, let's call this x. And we just have to cross multiply this. But again, if I notice that this, if you divide it by 21 is 3, and if you divide this by 21 it's 1. So that will make it much easier. We can go 1 times 57 is 57, and x times 3 is 3x. Divide by 3, divide by 3. You get x equals 19. So segment CG has a length of 19, and we've done the problem. Okay, in question 8, walkers in a park have different benches where they can stop and rest. How far is it between bench A and bench C? So they want to know how far is it from here to here. Well, I don't know how far it is because I don't know the length A to B. That's what I need to find out. So then I can add the two lengths. I can add the x to 536. Okay, now if we use the 3 parallel lines theorem out of section 8.4, we can make a proportion out of it, just like we did on the triangle there. We're going to get x is the top part over the bottom part, 536, equals, well, we can use this top part right here and compare it to this one right here. So we can go 210 over 336. Now we're not, the x isn't our answer, it's going to be added to 536. So when we do this, we're going to cross multiply, and we're going to solve it. So I'm going to pause it here and do the cross multiplying. So I cross multiplied 210 and 536. Got that big number there, and then in purple I did 336 times x. I'm going to divide by 336 to both sides. And that makes x equal 335. And people start looking for their answer and they can't find it because that's this part right here. But remember what they wanted? They wanted this whole distance here. So we're going to have to say A to C equals 335 plus 536. It's 11, carry the 1, that's a 7. It's 871, which is choice C. Okay, they want us to find the value of x, and we're going to use the triangle bisector theorem here. In other words, if the angle is bisected, so if we look at this big angle here, it got cut into two smaller angles right there. So because of that, we can now say that we can figure out that if we make a ratio of the sides that aren't cut, that's 21 over 35, it will be a ratio of the pieces here in yellow. X over 25. So you notice the small side gets the small piece and the big side gets the big piece in the same locations. So now we can cross multiply. 21 times 25 equals 35 times x, and now I'm going to divide by 35. Cancels out there. Here I'm going to divide by 35. I purposely didn't multiply 21 times 35 because I know I can divide them both by 5, and I'll get 5 and I'll get 7. So I know that's now 105 divided by 7, which is 15. Which is choice D. Let's do number 10 now. This is also a triangle bisector theorem. We can see that the big angle here So we cut into two smaller, equally sized angles. The only difference is when we go to do our pieces, we don't know this piece here. So we have one step to do first. Well, we know the whole thing is 52.5, so we're going to subtract the bigger piece from it. This bigger piece is right here. That bigger piece, if you subtract it from the whole thing, you'll get the question mark. So that's what I did there. And it's kind of convenient that the 5s cancel out, and you'll get 15. Okay, so this is 15. So let's make our fractions now. 37.5 over 15 is a fraction. X over 17 is a fraction. And we've got some yucky numbers to cross multiply, but we can do it. So 37.5 times 17 is 637.5, and that equals 15x from over here. I'm going to divide by 15 to both. 15s cancel out, and we get x equals 42.5, whatever the units are. And that's the value of x right there. That's that side right there. That was choice D.